To enter our rendering context, we could either put down a LAP network right here next to our geometry or anywhere else in our Houdini scene, or we can actually just use the stage context that's built in. So for this, I'm just using the stage. If I go to stage, you'll see I already have a network set up. I'm going to change us here into the Solaris desktop as well. It's really important, make sure you're in a Solaris desktop or the Solaris Look Dev desktop so that you get all the stuff that comes with Solaris and you have the rendering context set up here. We have a number of things going on here, and what we'll do is rebuild this network piece by piece. So to bring our geometry in here, we need there are a couple different ways to do it. And first, let me back up a second and talk about what we see here, because this is going to be a bit confusing if you have never played around with this. We have a viewport, which is also a rendering view right here. We have a geometry spreadsheet, which shows us our scene graph. This is everything that's actually in our scene for rendering. We have parameter windows, and then we have a little building stage here, and then we have some panels here, which are not important for our current needs, so I'm not going to get into it. I do want to say that USD in particular and Solaris as well are huge topics, and it's far outside the scope of this lesson to get into the particulars of this. So this is a bit more of a follow along lesson and a less, let's explain everything that's happening here, because this is massive. This is hours long to go through the entire rendering pipeline and everything that you could be doing here in Solaris and USD. Right. So what we want to do is bring in the geometry. If you imagine we have an empty network here, I'll just put down a null with nothing going on. This is the current state of our network. Our scene graph here is empty. We have no objects in here. We're rendering nothing. So one way we can do this is with something called a SOP import. We have a couple different things. We have a SOP import. We have a scene import. That's the other one I'm looking for. Scene import here. And then we have this other special one called geometry sequence, which I'm going to get into in a second. So a SOP import lets us grab a path from SOPs. So if I go in here, I can go and find our geometry, and I can go find the out in here if that's listed. Our output right there. Click there, and it will bring in the geometry. If I grab the scene import, I can basically look for a top level object. So that won't dive into SOPs. That only allows you to select the top level object there, and they will both bring in our geometry. If we open the geometry up, what you're going to see is that it's using the name attribute that we created to bring each of these objects in as separate pieces. Very useful for us, because as separate pieces, it means we can apply a unique material to each one of these if we want to, or target them individually, turn them on, turn them off, right? And see how that works. So that's why it's important to put name attributes on things. You'll notice that the name it gets here is Geo1, and that's because it's getting the name straight out of our Houdini session. In SOP import, you'll notice it's getting the name SOP import number 1, SOP import 1, and that is because it is using this operator string here saying get the name. $OS stands for the name of the current operator, my operator, saying I would like you to call myself whatever I'm called here. So if I just call this test, you'll see that changes to test, and we still have the pieces under here. So you could call this something like cloth, and you'll get a group there called cloth. One thing you'll notice as you scrub through here is it's fine, it's fairly performant, but when you go to render this, it's going to want to write this data out a lot. It's going to recache all this data This is a kind of particularity with how USD works. And there's a much more efficient way of doing this, which is to use this geometry sequence here. The reason I'm using this is this allows us to reference something that's directly on disk, which is this pretty dense sequence of geometry. If you didn't have something like a cloth simulation or a fluid simulation, you had something that was a lot less dense, you could probably get away with using these regular importers here, but because this is a bit special, we're going to use this geometry sequence. So if I use geometry sequence and I go and find our cloth, we can just bring that right in. And again, you'll notice it's actually a much faster playback and everything is brought in here. So if we want to change the name of that, let's see, what did we name it over here? We named it cloth. So I'm just going to copy and paste that over here. All right, so we have brought in our geometry for rendering. Fantastic. Now I want to be able to subdivide this at render time. So the way that I do that in Solaris is to use a node here called a mesh edit. At some point, hopefully they will give us an alias called subdivide, which has some of this stuff filled in. It's a good RFE, so maybe somebody will suggest that. And we can change the subdivision scheme here, which will allow us to enable Catmull-Clark subdividing. So I can choose set or create. It's going to change that to Catmull-Clark, but we have to tell it which pieces of geometry that we want to apply this to. That's what this value here means. So if I hold down Control and I click on this arrow, so I'm holding Control, clicking on the arrow, that will pop up this window here. I can select all three of these and click OK, and it will bring all three pieces of geo in, and it will apply that subdivision scheme at rendering time. Another thing you can do is you can replace this stuff with wildcards. So instead of saying /cloth/piece, you can just say /cloth and then star means everything underneath it. And now that subdivision scheme should be working. I'm not seeing it actually updating in the viewport here, but we'll do some error checking in a little bit. It should be exactly the same as over here. It might just be that we need to kick some stuff off here. I'm just going to do that and initialize a render. I don't know if you saw that. I went from our GL view into a Karma CPU render, and you'll notice now that everything is nice and smooth. If I disable this mesh edit here, you'll see we have that faceted, non-subdivided version, and here we are subdividing at render time. You'll notice that rendering happens right here in the viewer window. I'm going to go back to our GL view. We can toggle this on and off just to see the results. So kind of interesting, it's updating the normals. I'm not sure it's actually updating the geometry in the GL view, and that's fine. Next, we need to put some materials on this. However, you'll notice we don't have any materials in our scene graph, so we have to make something. To do this, we need a material library. And this is just a storage place for all the created materials that we want in our scene. Now, there are lots of ways to organize this. You can have material libraries associated with particular pieces of geometry. You can have material libraries that get referenced in off of something that's been written to disk. There's a lot of ways to do this. Again, this is just a quick demo and walkthrough about how we might render this particular thing. So in here, we're going to go in here, and I'm going to find the material X node here, and I'm going to build a USD material X builder. Now that creates a new material here called material X material. You'll notice now that we got a new little category in here called materials, and our material is appearing right underneath it. I'm going to change the name of this to cloth, and you'll see that updated there. If I double click and dive inside, we have some stuff already set up for us. We have a material X standard surface in here, and here is where we can adjust properties and we can wire things into it and go crazy with making materials. For now, I'm just going to change this to a red color just so that we can see it when it's applied to our geometry and make sure it's working. And then we'll go back and do some tweaks. So just because we've created a material library doesn't mean the material is applied to anything in here. We actually need to create material bindings. If you go into your settings tab here, you'll notice you can get a column for materials. I'm going to click that. And let's drag this over a bit. And you can see for our materials, we have nothing assigned to anything. So let's fix that. I'm going to use a material linker for this. Take that, put that down, wire that in. And on one side, we get a list of all the materials in our graph. And on another side, we have all the geometry, and we have to match them together. So I can take cloth and I can drag it over here into our rules. I can turn off this filter based on selection, which means if I deselect, this thing will still stay here. And now I have to choose what objects are assigned that material. So if I go into cloth here, I can grab all 3 of these and I can drag them in, or I can do something like this. I can drag one in here, and now you'll see just piece 0 is applied. I can click on here, and if I wanted to, I could replace this with a star, and you'll see it's going to show us all 3 of these are now going to be given that same material. Click accept, and now they all have that material applied to them. So that was pretty easy. Let's go back into our material library, and here's where you can adjust however it is you need. If you want to grab my settings from the other material, you can. One thing to note in my other material is I wanted a bit of translucency in here. To enable translucency, you want to go to geometry, turn on thin walled, and then the translucency is actually controlled by your subsurface parameters in here. We'll leave this as is for now. Maybe we'll just take our specularity and we will just, bump up the roughness a bit so it looks a bit more cloth-like. Okay, now we need to get a camera. It just so happens that out in our main object context, I have a camera that I have already set up for us. It's right there. We'll go back into stage and we want to import that camera. So to do that, we need a scene import, and it will just grab cameras here. Now our camera is imported into the scene. It's right there. Now that we have a camera, we can actually look through it. So I can select my camera, and we're seeing what the camera was seeing, which is great. So I have depth of field on this camera, or I would like to render with depth of field, but I never actually set my depth of field focal point on here. Oops, I guess we can fix that right now. So let's go into a side-by-side view, and here we're in perspective, here we're in our camera view. So I can tumble around and I see my camera out here, but I have no way of editing the camera properties. There is something here called a camera edit. I'm going to put that down here, grab my camera, make sure this is what I'm viewing, and I have to tell it which camera I want. Now before, we had just control-click here, and we got this nice window, and we could grab our camera. Another way to do this is to just drag and drop if you wanted to, and now my camera's in there. I have to go over to my sampling tab, and I have to go find my focus distance, set or create that. Now I have this nice little handle that I can drag around here. So that will be our focus distance. The f-stop is set to 0. A value of 0 f-stop essentially means do no depth of field blurring, disable. I'm going to change this to something pretty low so that when we do render, we're going to see the effect of that. Let's go look in our view here, and I'm going to go back to Karma CPU, and you'll see now that there is definitely depth of field happening because that's further out and it's blurring that image, and we've got some sharp points right in here. All right, we can go back to our GL view, and let's find out what did we choose for our f-stop before? 0.15. All right, we'll grab that. Now we need to add lights to our scene. So I'm going to add an area light. I'm going to wire that in. And here you can get nice and artistic. You can move your light around. We can change the intensity and the exposure. We can adjust the width. And what I'm going to do now is we'll look through the camera here. So we'll look through our camera and we'll start a viewport render. I'm going to change this for the sake of speed. Instead of using CPU now, I'm going to use XPU. Depending on your hardware configurations, you might not even have XPU as an option. But typically I am using XPU for my rendering in here. If this is the first time you've used XPU in a while, you might get stuck on compiling for a minute or two while it builds up all the shaders and stuff. It's rendering very dark right now. Let's see what's going on here. Go back to CPU for a second. And I think it's because my light might actually be pointed the wrong way. So let me go into side-by-side views. And yes, I think my light is actually pointing the wrong way. So let's turn my light around so it is actually pointing at my geometry. All right, I'm going to go back to XPU and let's bring that exposure down. All right, so now we are actually starting to render and we're lighting. At this point, if you want, you can go back into your materials and you can start tweaking them. I mentioned before that I had enabled this thin-walled parameter on here and subsurface, right? You can see once I start dialing that in, now the light is actually starting to penetrate a bit through the cloth. So it looks a bit more natural and cloth-like. And this one is a season to taste, but it shouldn't be that strong, right? It kind of depends on the cloth that you're making. I'm not going to go in depth into materials here, but you can play around with this however you like. You want it to be silvery metal cloth, go ahead and make it metallic. It's up to you what you want to do. Play around, have some fun. Let's go back to our stage here. And I'm going to go grab my area light and I'm going to just copy and paste that. So we have a copy of the area light and maybe we'll do cross lighting here. You'll have my other scene, so you'll see exactly how I set that up if you want to match exactly what I did. Okay, and maybe this light is just a little bit of a very subtle fill light down there. All right, so we've got some lights in our scene. Now, the other thing I did is I wanted this nice little fog to go over our image here. I wanted it to look like it was in a slightly dusty environment. And to do that, I used a Karma fog box here. So I'm going to type the word fog, grab a Karma fog box, and put that in our scene. And right now it's just a box, which is what it is. But I'm going to make that much larger so that it is in the entire scene. We're going to probably have to compile again because I don't think this shader has been compiled yet to be used. And now you'll see we get this lovely fog effect over our image. And it is volumetric. It really is working. So you can change the density if you want to something very subtle. You can go super thick, too thick. It's up to you how you want to work with this. I won't get into the settings here other than to just say, go ahead and play, use it, don't use it, season to taste. And then finally in here, we actually want to set up our render settings. So at this point, I'm going to just go to our GL view, and we'll go into a single view here. And we will put down a Karma node here. Place this down. You'll notice it drops down 2 nodes. We have to connect into here, and there's a warning. We middle click here, it's going to tell us it's looking for something called cameras, camera 1, and it is missing. It has no camera in the scene called camera 1 that's located in this path. If we actually look here, we have a camera called cam 1. It doesn't match what's in here. So we need to fill this out correctly. I can just grab my correct camera, that warning goes away, and now it can properly compute everything it needs. So our resolution, set however you like. For now, I'm going to keep it at 1280 by 720. And you'll notice the rendering engine here. So even though our viewport is seeing one thing, our render engine is actually doing something different. And you'll notice if I render this in XPU, we're getting a little warning here. It's hard to read over the grainy type, but it says the settings in the viewport do not match what our render settings in the engine are. So it's giving us a warning. What we might be seeing here isn't actually what's going to get rendered out to disk. So you typically want to make sure that these match what your render engine is. So if we're rendering XPU, we should be on XPU. And now this is going to be using the render settings that are actually in this node instead of the default settings in the viewport. Here we can control the actual quality and sampling. So for instance, if I put this down to something very low, like 10 samples, you'll see it renders very, very fast. 2 samples, right? Super, super fast. But this is actually the final result of our rendering. This is our quality slider here in XPU. So we'll put this back to 120. You'll notice our results still might be a bit grainy here. If we want to enable degrain, we can go into our image output here, go into filters, and we can put on our denoiser. You have a choice. If you have an NVIDIA card, you can use the optics one. Otherwise, go ahead and use the Intel one. And it actually just applied the degrain. So if I bring path trace samples down to something like 2 again, you'll see how fast that is. If you render an image sequence this way, it's going to be pretty blotchy. It's going to have definitely a lot of denoising artifacts in there. So you need at least a decent amount of samples if you're going to use denoising. It's more or less a final smoothing there. So typically I'd be at usually minimum around 120 with some denoising on there. And that will set us up in here. And then finally, we need to write this out to disk. So this would be how we'd write it out to disk. We would press render to disk. However, we did not actually set up a render output path. There is a default one in here, and that's the default one. So if we do nothing, it's going to render into a directory called render. The file names will be our name of our HIP project. So that would be called cloth example 01. And then it would have a dot, and then it would be called Karma render settings 1, and then it would have this path over here. If you middle click on output picture, you can actually see how that expression evaluates. And I don't quite like that. So maybe we would call this one cloth render. And then we'll keep all this, middle click here, and you can see exactly where that's going to go. Cloth render. All right. Once that is set, you can do a couple other things here. We can go into our output here, I believe. No, that's not the one I'm looking for. Let me just find exactly what I'm looking for here. Yes, it is an output, and I'm looking for maximum threads. If I enable this, what it's going to do is we have -1. What that's going to mean is don't use every thread on my computer for rendering. Leave at least 1 for the operating system. This can be really useful so that it doesn't lock up your computer. I like to leave that on. And then the other thing that you can do, you have a couple different options here. Obviously, you want to change the frame range. So you want to render your full sequence or whichever frames are interesting to you. And now you have this button here. So if you render all the frames with a single process, what it's going to do, and this is really important, this is where the USD stuff really comes into play. If you have your USD files set up correctly, it's going to create one single USD file of your entire scene and then bring that into the rendering engine and render that straight up. It's a much faster way of working. However, it means you have had to have already gone through the work and prepared your scene correctly for USD and efficiency. And that's just way outside the scope of this tutorial. However, one good thing we did by using this geometry sequence node here is we are pretty much ready to go. So we can choose this and we'll get a much faster render and it should be just fine. If you find you're getting weird rendering errors, you might want to turn that off. It's going to be slower. What it means is that every time that it renders a frame, it's going to generate a new temporary USD file for that frame, then pull that into Husk for rendering, render it out, and then goes through that process again. So it's quite a bit slower. But when you're ready to render, you can go ahead and click Render to Disk. The other thing is you'll notice you're not going to be able to see this in any sort of monitor. You're just going to get a little progress bar. If you want to be able to monitor the rendering as it's happening, you can click Monitor over here and enable the MPlay monitor. That should pop up a rendering window for you when you go to render. And to enable motion blur, by the way, on the render engine, you want to go over to rendering here and you want to go to the camera effects and you'll see that we have already depth of field and motion blur enabled. One thing to know is that we are using velocity motion blur on here, which is going to use that velocity attribute, the V attribute that is on the cloth. And that is not enabled by default in our render settings. So to enable that, you will take the velocity blur here and you will choose velocity blur. You can use acceleration blur if you have an acceleration attribute on your geometry. Since we have V, we're going to use velocity blur. There's a little bit more to know about using this per object motion blur, which should be able to be used. However, we didn't quite set our project up to use that. If you're interested in learning more about that, this stuff is explained in the Houdini documentation. One quick thing to note is that there is a motion blur lop that you can use that has a bunch of this stuff in here, and typically that would just go in between and then you could render like that. Again, there's a lot more information to know about motion blur. It probably takes about 10 or 15 minutes just to discuss that topic. So that's why I kept it simple. And I said, we'll just use velocity blur and render this way. And that's it. That's rendering. That's the intro to it. We have gone through a full project here. I think there's one other quick thing to mention, which is that I do have ACEs enabled in here, and that's way outside the scope of the tutorial. But if you're familiar with ACEs and different OCIO configurations, I highly recommend using them. The renders look much nicer. So if you don't have ACEs, you might not be seeing the exact same results as me, but that's okay. You can adjust as needed. But yeah, so we've gone through the whole process of how this was built and how it was rendered and how it was put together. And you will have the example file. That is the exact identical file I used in my render. And you feel free to pick it apart, make changes, and explore and see what you can do with it.